Thanks for tuning in to Stay Sharp with Razorleaf, your secret weapon for all things digital in manufacturing. Since we just scratched the surface in this first episode of Unpacking the Essentials of CLM, which stands for Configuration Lifecycle Management, we invited Anders Rasmussen from Configit back to the studio to continue the conversation and to further expand our understanding of this technology. What is the impact to the business when buyers buy a single instance of a Configit product? What are those ripple effects? Can an engineer-to-order manufacturer adapt parts of their process to support configure-to-order? We even touch on how this impacts the digital thread. This episode is packed with good information. Let's listen in with Jen, Jonathan, and Anders and complete the primer for configuration lifecycle management.
All right, everybody, welcome back to Stay Sharp, the podcast about all things digital related to products and manufacturing. I am Jen Ferrillo, and I am here with my co-host, Jonathan Scott.
Hi, everybody.
And today we're having our second conversation on configuration. And the first one, we covered some of the basics, the why, the what, the how. And if you weren't in on the first one, make sure to circle back to that. It's got some really good conversation there, really good topic coverage. But today we're digging in deeper to some of the benefits, including some of the ones you may not have considered of configuration itself and managing all of that configuration data. And last time we added a new acronym, at least a new one for me, which was CLM, Configuration Lifecycle Management. The LM appendage there is getting very popular, it seems like. I would like to welcome back our special guest, Anders. Anders is a senior principal software developer at Configit, a company whose very business is centered on helping manufacturing companies master the challenges of configuration. Anders, can you tell our guests, perhaps the ones that haven't been in on the first conversation, just a little bit about yourself and Configit?
Sure. Yeah. My name is Anders Rasmussen, and I work for a Danish company called Configit. And we are a company who helps manufacturing companies that have complex products get control of their configuration information. So we are a software development house. We do tools and products to help people get into what we call the configuration lifecycle management space. So that's basically ability to take your configuration knowledge, your definitions of your products, how they can be configured, means the different aspects of what you can offer, and then bring all the knowledge together from your engineering, your sales, your manufacturing, your service department, etc. So I think that was the short version of what we talked about last time. So configuration lifecycle management, basically in a short sentence, is the ability to take all the knowledge, your product specification you have from the different disciplines that defines your products, and then bring that together into one coherent big thing.
Yeah. And I think that was one of the terms we talked about last time. You know, the relevance to folks who might listen to the podcast was mass customization, right? If that's something that resonates in your business, in your organization, this is the right topic for you, right? Because the idea that you just described, Anders, of, how do we look at that challenge across the organization, across all the functions? That's CLM and what CLM's about. So that redefinition or summarization, I think, is good for everyone to kind of orient to what we're talking about and why this is relevant. And digging into that a bit, who's that relevant to? I hear things in the market where, everybody's mass customizing, and I hear other things that no, we sell what we sell and it is what it is. But I mean, from your view, what types of companies or products is this the right fit for, the best fit for, or should be paying attention to it?
Yeah, so I think this is something that any company who have products that have a large degree of variance should pay attention to, because handling that variance is enormously complex. So I mean, you can say in short, it should be to all the companies who know what the complexities of handling variance is. And I would even go as far as to say that's all companies who have variance in their products.
Right.
So this definitely applies to especially manufacturing companies that have products where they let their end users have a high degree of influence on what it is they deliver. Not just very specifically customized products, but also something that you might have to have choices on and put out in large scale.
But I think you're hitting at an important point, Anders, which is don't tune out if you think, oh, well, my business, we don't configure our products, or we don't have a configurator, or that sort of thing. Like, don't immediately tune out, because really it's about complexity and variability of product and what you offer, or even what you want to offer. And that's something I've heard, in other conversations, other contexts in our industry. I'll throw another word out there, right? Product line engineering and PLE, right? So as you think about what you offer to the market, if you think about it having a breadth or more capabilities that you might bring to your customer, you have to think about this variability. And I think that's what you're getting at, right? Is you don't have to think of yourself as a mass customization company for this to make sense.
No. So product line engineering, that really talks about the first part of the life cycle of a product, when you are handling the different capabilities of your product, because that's also handling variance, right? You might not be pushed out all the way through the chain up to your customers, right? They might not see everything you can do, but when you're dealing with your products, when you're designing them and engineering them, you are dealing with the capabilities and the you can say the intricate challenges of some capabilities being complied with other capabilities, right? So I think actually there are some really nice ISO standards made on PLE. I think the latest one is from 2021. That actually it's worth a read, because it does a few things. It puts a bit of terminology on what is it you're working with. Last time we talked about features, for instance. So it defines features, and we mentioned configuration there. I think they call it the bill of features, which is just a selection of the values for your features that defines a configuration. So PLE is part of this CLM story, really, you can say, because it talks about configuration from the engineering perspective. CLM is a bit of a broader picture, because it talks about how to bring the different disciplines you have, the configuration aspects, together. So it could be doing PLE on the engineering side, and that has influence further downstream. But there would also be other ways of handling configurations in how you sell it and service it, and decommission the product and transport it, manufacturing, etc.
That's good context, Anders, for sort of putting PLE as a piece of what you might do in overall CLM. And thank you for again helping us with the terminology here. Right, it's challenging to have the right language to talk about this, and if some of what we talk about today to our listeners, doesn't sound familiar, doesn't sound right, please go back to the other episode, because we did spend a good amount of time talking about words, right? And features, characteristics, variants, all these things. And there's no standard language, but at least we can talk through and understand the concepts to be on the same page with each other.
One of the things I found really interesting that we discussed last time, because it's, when we're talking about configurations, like Anders has said, like I've always viewed it from the sales side of things that customers could choose and not choose. But, one of the things that you had touched on last time is specific markets having specific requirements, whether it's, we were talking about the car example in African, like those always come with air conditioning. They have to, and same results. And that's something that the customer would never be exposed to, one would assume. Why would you ever in Africa choose no air conditioning? But, it's stuff that is engineered that way, and it's just not exposed.
Yeah. So configuration is I like to think of it as the data behind configuration is a definition of your products. It's everything you know about them from a capabilities point of view and from a restriction point of view, how things fit together. Obviously, there's more to a product, right? There's a lot of documentation and requirements gathering and simulations, etc. But it's a driver for aligning what it is you can do with your products as you look through the chain of the life cycle of a product. And it's a good way to think of establishing a common ground for communication across disciplines. Another thing that we didn't talk too much about that, but because we talked a lot about CLM being the definitions of your product, right? Your definition of your features and your rules and how they have to fit together. But the interesting thing is all those definitions, they're used in your daily work. But at some point, we have customers who buy our products, right? If you're a manufacturing company,
you hope so.
Yeah, that's the whole point, right? And we want to get it out there, and we want to get all the capabilities out. But when they buy the product, they create what I would call a configuration. So that's an abstract definition of what they bought, right? We use the pump example last time. So they know they bought a pump that can pump this type of fluid with this elevation, with this flow, made of metal. Maybe they want a small plate saying, pump is hot, don't touch, because it's somewhere that people can get to, et cetera, et cetera. It defines the product. But now it's not just a definition of the capabilities of your pumps, what they can do, your whole portfolio. Now it's a single instance, something that would eventually be manufactured and turn into a physical product. That thing has a configuration to it, a specific thing that defines, this is my product. Actually, if you take a vehicle, if you go into an Audi and you open the glove compartment, you'll find some small codes there. Those are the feature codes that were used when you configured your car. And that's kind of interesting because not only does it follow the car because it's a sticker in your glove department, but imagine you have to service it later. That specific vehicle that was sold, you have to upgrade it with software. When that happens, you have to be very specific. You have to know it's not just whatever brand and make you made. It's with certain specifications. So, for instance, if you're trying to upgrade software that makes the rear view camera more smart, you have to know whether that came with all the sensors that enables that camera to be smart, right? And maybe it only came if you configured it with the adaptive cruise control because that has extra sensors to it. So that configuration basically is not just about aligning on everything. It's also a specific configuration for a specific product that follows the product through the life cycle of that product after it's been delivered, because it needs to be serviced. Sometimes it needs to be upgraded, maybe decommissioned and replaced. And if you're in let's say you have a factory with large complex products, you wore down your machinery. If you want something to replace it, you would like to know how did I get my original machinery in? And that's not about parts and components. It's about the configuration that led me to get that machine, right? So what you really want to do is you want to take that configuration, give it back to the company that sold it to you, and say, I want something that does the exact same thing. Of course, a little smarter, a little cheaper, a little faster, and everything else. And maybe you add a little extra thing to it, right? But that's a thing that follows it. So it's just the other side of the specific configuration living on the life cycle of a product.
I love that example, Anders, about the sort of upgrade, right? Because that's something that comes up for so many customers today when they think about, they're ready to pull their hair out. They say, look, I know I want to offer my product as a service, or I want to, I want to recognize some of the profit that's in the aftermarket or the upgrade space or whatever it might be. But they're changing their business model and they see these opportunities. But the reason they pull their hair out is they say, I have no idea how I'm going to deal with that and manage all the complexity of the product I have to offer in the first place, right? Yeah. So I know I have to have the mass customization of the product up front to serve the market and to win the market share. But when I do that, I've exploded the complexity in a way that I have no idea how I'll deal with it when it comes time to offer an upgrade, offer a replacement part, that kind of thing, right? And even, the systems to manage that. And I won't dive too deep now because I'm going to save a question for a little bit later. Right. But this gets to that digital thread point. And when you say configuration lifecycle management, that lifecycle and really understanding, it really does go all the way downstream. Your example is a great one.
Yeah. So it is. We actually do talk about the configuration digital thread. So it is the thing that connects your product from up to where you decide what to get in manufacturing, but also after it's been manufactured. So we actually have some a very interesting case in one of our customers that manufactures some extremely complex machines in the semiconductor industry. These machines, they live for a long time, right? So it's a huge investment. It's basically a whole factory. And what happens is that you need to keep them alive, these machines, because it's a very big investment. So you want to keep manufacturing on it and you want to tune it and upgrade as you go along. And the thing that drives that is basically the configuration of that product. So what happens is that as time evolves, your model, that's your product model, and your bill of materials, right, and all your calculations and simulation models, they evolve, but you still have your configuration of that old thing sitting on the factory floor, right? But you can go in so many years later and you can pull that in, and now you can see what happened right? You apply the same configuration, and then you drive your whole bill of material explosion, your simulations, etc. again. And now you can start comparing and figure out, okay, what are my capabilities? Maybe it can do more than you thought it could do. Maybe if you want to replace parts, you can figure out what has changed because you can compare it to the original bill of material that was driven when it was manufactured and the new capabilities. So there's definitely, there's a piece of information that you would really like to carry along your products when you are dealing with mass customization, and that is the configuration, because we usually like to think of it as the DNA of the product, and it's especially interesting if we go to the full scale that we talked about previously, where your configuration is not just what the customers selected, it is the full set of features, right? It's the customer might have selected a few things, and what happened is that all the rules we have from engineering and from sales, etc., ties all those features together. So some of the technical features from the engineering space would be fulfilled. Maybe an engineer has put more onto it. So you have the full, basically DNA of it, like what the engineer's point of view is, what the customer's point of view is, what the sales point of view is, and that should follow the product as we go along.
So you're making my head explode a little bit, Anders. This is great stuff. The idea of that, the digital thread or the configuration thread later in the life cycle, is one I've never really thought much about, right? I think about service and upgrade and repair very much from a technical perspective, right? Very much from the, okay, you swap out this component for this new upgraded version of it, and now that product is upgraded. But I don't think many organizations consider, well, did I look at that from a product configuration perspective, or was I just swapping components, right? Was I just offering a new kind of one-off upgrade? And that idea of, well, I have to keep the configuration up to date as I would like an as-built or as-maintained bill of material. Do I have some as-maintained configuration and recognize it has its own life? This is an interesting concept.
Yeah. It takes a lot to blow Jonathan's mind, too. So you should be impressed. You should be proud of yourself.
The interesting thing is because a configuration is just another representation of your product, right? But it's
right.
Dealing with features, and they are abstractions. It's a higher level thing without going down to the individual bolts and nuts on your machinery, right? So yes, you want to keep all that information along with the that's what the digital thread is, right? It's trying to keep all the information around. But you also would like to keep hold on the abstraction because it's easier to work with. And if we get to this configure to order, or at least in that direction where we can start working on the abstraction and then deriving the rest of it, we can do a lot more, right? Because we can continue that process, not just at point of sales, but also at after sales and upgrades, etc. So I think to me, when you say digital thread, it's just a natural thing for mass customizable products that can be configured to put the configuration in there and keep that up to scratch with the latest changes you apply to your products.
And I think that the part that is probably so challenging there is you have to think a little bit about that ahead of time when you're defining or designing your digital systems and your solutions that are going to support how you do it, right? That concept makes sense, right? Now that you've kind of talked us through it, I buy it. That's why it sort of blew my mind. I'm like, wow, that's something that hadn't really occurred to me before, but it makes sense. It's logical. Now, how, right? And do you have to put it in place up front? And those are challenges for people to think about, that if you really are going to maintain that thread start to finish, not just on maybe the detailed definition of the product, but your abstract representation of the configuration of your product. How does all that fit and align and connect and that sort of thing? I don't know. Do you have any thoughts for us on that?
It is. I don't think there's one standard to fit them all because it's a hugely complex thing. But if you want to distill it into one piece of observation, it is that you don't want to lose information. You start with your abstractions and you get to your details. So don't throw your abstraction away. Keep it because it has value further down. So if you're working on the abstraction level, you can basically reapply all the benefits you got when you were leading your product all the way up to the point of sales and configure to order, right? Because you still have the abstraction and and now you're working against the updated data. How does the world look like today? What is my rule set? What is my bill of materials? and all the rest of that. So don't throw the overview away, right? It's like having a book where you pretty much tear out the index, right, and you're left with all the pages you have to read through. So keep the index. It's part of the definition of your product.
Well, and the thing that's interesting to me is, Jonathan, you just said, like, do you have to think about this all in the beginning? I think in anything that you start like this, that's the ideal, right? But I think it's also, at least it seems to me that it would be also very easy to, with an existing product, say, okay, you know what pieces and parts of these do we want to allow the customer to change? If you haven't already introduced engineer to order, custom or configure to order, and what ones do we not? They're driven internally by whether it's market or engineering or capacity. But these are the pieces, and then you can basically build that abstract concept after the fact, and then run forward with that.
Yeah. And I think last time we talked about motivation, and we said, it all comes down to money in the end and making money, right? But if you can control your product after it's been sold, you can upgrade it, you can service your customers, you can even do upsells, and at the point in time when they decommissioned your product and want a new one, you can be in a much better situation to be the supplier again if you got control of everything there is to know about that product. So keep the configuration around. That's a valuable piece of information.
Well, and I'm gonna state a takeaway from what you guys just mentioned, and tell me if you think I'm right here. Which is, it also means that you don't have to start at the beginning, right? You don't have to say, well, I can only do all this CLM idea and concept if I'm doing a new product development. You can come in maybe in the middle of what you're offering and say, you know what, if there's, and Anders, you made a great point, if there's money to be made in tracking from what I've already delivered downstream through upgrades, through service, through whatever it might be, great. It may make sense to start there and move downstream and then work your way back up, right? I mean, is that fair?
Yeah, I think it's fair. It's because, you have to start somewhere. And we don't have to be in the fully ideal scenario where all our systems are connected and talking to each other and there's no manual process of moving back and forth. That's not reality. That's not how businesses work. But you're going towards that. And one of the ideas and one of the concepts we like to work with is this idea about being live from day one. Basically, what it means is, as soon as you start applying these processes of getting the abstraction of your products in place, and you start applying your rules about how are things connected, as soon as you do that, you can start to get information, because you're basically doing two things. You're documenting your product in a very solid way, and you're getting the ability to interact with your documentation. Right? It doesn't have to be perfect, but everything if that's actionable, and that's the whole point about creating configurators, because they're actionable. You can interact with them, you can analyze with them, you can see what happens, you can simulate, etc. So as soon as you get to that point, you bring value. So don't wait until everything's aligned and all the stars is in one row, etc. Just get started. I mean, that's the point.
So I want to draw in a parallel universe to this, right? That I think, well, we talk about the same thing with some of our customers, about you don't have to start at the beginning. Don't wait. If you see value, jump in. We probably talk about that in a number of concepts. But model-based is one where I see a very direct connection to what we're talking about today with CLM, right? So in model-based enterprise, we've got all these domains that maybe have their own language, model-based definition or model-based quality or those sorts of areas. And it connects to a full enterprise and a full story. It helps give a common language, right? If you're sharing models across the business, you see more value by keeping that and keeping a thread. What do you see there, Anders? Do you see that, that model-based enterprise concept supports some of what people should do in CLM, or it's going to raise some interesting challenges, or what do you see there?
I would almost say that all the motivation for going model-based and sharing that in a digital thread is almost a CLM story. We just tell it from a configuration perspective, right? Because if you look at what drives configurators, it is what is called a product model, or some call it a feature model or a rule model. So it's not a model.
It is a model, right? It is a model. So
but it is a model. Exactly. Right. So it's just a part of the model that's giving a feature language which is my abstraction of my product, and giving my product definition from what I know. If I'm an engineer, I know about my technical capabilities and how they interline. I probably know about legal requirements, etc. And the salespeople, they know how they want to bring the product to market. The manufacturing thing, they would know whether to weld the both things together, depending on if they're transported or truck or ship, etc. Right? All of that is product definition. All of that is captured in a model. And each of those models that flows down as like a digital thread should be aligned. So CLM is basically, let's make sure our product models, are those product definitions from a configuration perspective, get aligned throughout the life cycle of that product. So I think it's very much related, to be honest. I think model-based approach is like the foundation for doing configuration. But when people talk about model-based engineering and model-based systems and enterprise, etc., they're probably talking about a somewhat a larger picture. But there's a lot of parallel similarities to that.
Well, I love the way you tied that together, though, by saying, in CLM, one of the first things you need to discuss is a feature model, right?
Yes.
Because that's exactly what you're doing. You're defining, conceptually, what do you have? What's allowable? What do we and don't we do? All those things. And that's what so much of what we do in the product development space is today. We might not have called it that 30, 40 years ago, but we're modeling our understanding of something. And in this case, modeling configurations, modeling that concept so that we can use it in other places. And if we can really connect it through CLM, right, throughout the life cycle, through down to the technical details, well, great. Now we're sharing models, the whole point of MBE. So I love this.
Yeah. So I have a question, because you just said we may not have called it that 20, 30 years ago. Did we call it knowledge-based engineering?
I think that's one label for it, maybe. I mean, Anders, what do you think? What have we called this in the past?
I think there's a lot of terms that have been floating around, and I think the whole it's basically just a realization that you don't communicate in specific documents on small details, right? You communicate in intent, basically, more than results, and you can almost say that from a configuration perspective, that's basically what it is. Your intent about your product is your feature model. Your result is your configuration. But you can apply it everywhere else, right? It's a great way of being able to provide what you want. I mean, everything you know about what you're working with and your intent of that to make it actionable further downstream into other people. That's basically the whole thing about model. I'm not sure what label to put on it, to be honest, but you could also call it common sense almost. Right? I mean,
no, it's just like that's, I remember in the beginning of my career, KBE was a big deal. It was that was the, knowledge-based engineering was kind of the newest concept. And this seems like the latest permutation and a much more advanced one than that.
I just love the fact that we're using the word model and getting away from everyone's immediate connotation that it's 3D. Right? That's like, I love 3D, don't get me wrong, but it's like so many times now it's like, oh, you say model based and everybody's like, oh, you're talking about 3D geometry.
MBD, yeah.
Like, no, we're talking about more, right? So this discussion is just a reminder.
That's not the whole thing. Yeah.
Right.
Exactly.
And that's what I mean, a lot of our conversations are about is engineering is part of it. It's not the whole thing. We're all very engineering focused, I think. But one of the things I wanted to ask about, because we focused primarily on the product and the value, basically to the market. What are some of the other areas that configuration and CLM kind of touch on and challenges that it helps address? I think you had mentioned at one point, like supply chain management.
Yeah. So one of the things you can start doing when you have these models and you've shared it and you combine them is you can start to create some transparency. So if you're engineering your product disconnected from how you're selling your products, you really have very little control if you're trying to sometimes sell things that is either technically illegal or you cannot manufacture because your model about manufacturing is disconnected. So that's what people usually talk about. People sell things that we cannot manufacture, but you can also turn it around and say, am I engineering things that you don't want to sell? Because if that's the case, I'm probably losing money, right? I'm putting effort into something that, I'm building the cars we talked about without the air condition for the African market, but no one wants to buy it. So Stop engineering that and simulating that. There's certain industries like the car industry. If you have a part, you have to maintain spare parts and upgrades and documentation for that for many, many, many years going forward. So if you can catch it up front and basically find out that piece of whatever drives the usage of that part is not a realization because no one wants to sell it. It's not offered anywhere. Then you can begin.
I'm going to jump in, Anders. I'm going to jump in because you just gave me another okay. We've, in the PLM space, a lot of vendors spend time talking about search engines to help companies avoid part proliferation. Reuse that part. Don't make another part number for a new part number. And one of the points they make is a part number is an expensive thing because of exactly the point you just raised, right? Once you've introduced a part, you have to maintain the documentation and the inventory and all those things. And you're mentioning a different perspective on that, which is, hey, let's say you do kind of make that mistake or you have introduced something, you have something in your portfolio that maybe you don't need. CLM can help you see that, could help you understand that. That's something that I don't need or I need to work my way out of because it's no longer relevant. That's really interesting.
So maybe I can get a few examples of how this is being approached, right? So when you're working on the engineering side with configuration knowledge, you have your technical rules, you have your technical features. You can drive a configurator and create a configuration. So ultimately, if you want to automate everything, what you want to do is you want to get a bill of material that's also configurable. Some people call that a 150% BOM, an overloaded BOM. It has, again, terminology. It has a lot of different names, right? But what you want to do is you want to get to a place where you can take a configuration, apply it to this 150% BOM, and then get what is often called a soft BOM or a 100% BOM, a bill of material that has the exact parts you need to manufacture the configuration that you put in, right? So imagine that you can go to the sales side and say, I know that certain markets have certain restrictions, certain campaigns are running, etc. So this is what we bring to our customers. And basically describe that as, we call that a solution space. But it's all the billions and trillions of combinations that you could choose from. These are the things we offer, right? It's the whole thing about mass customization, that you basically search within your configuration space to find the thing that is most optimal for you. And it has to be valid because it has to apply to all the rules. But if you know all those rules are built as a combination of all your knowledge from all the different disciplines. So what people want to do sometimes, they want to take that information and bring it down to the bill of material, because the configurable bill of material have, and here's again an overloaded term, selection conditions, usage expressions, whatever they're called, but on the different parts in an overloaded structure, you have information about when to use which part. So if you're selling vehicles, sometimes you need the rear view camera and sometimes you don't, right? Sometimes you have 10 different side mirrors, and it depends on what goes in and what goes out. And you don't get us started on wireframing, for instance, right? Because that depends on a lot of things. So an interesting observation here is if you have your combined knowledge as your rule set and you have your bill of material, you can start to overlay those two things. And that's when you get to these very interesting pieces of analysis. Do I have parts that can never be consumed? Or even worse, do I have variants that I'm offering that if I apply it to my bill of material, I get a solve that doesn't meet certain criteria? So for instance, whenever I sell a vehicle, I know there has to be a front seat for the driver and one for the passenger. And if the selection of those depends on your configurations, you don't want to have the configurations where one of the seats are missing, right? You might also have part-to-part combinations. If you're doing simulations on brake systems, you have a brake, you have a suspension. You don't want to put a brake in and a suspension in where if you drive over a bump, they hit each other. So there's a lot of things in there. And that's the optimization you can start to get to if you combine all your knowledge, because now you can start to take knowledge not just from your own discipline, but from the other disciplines, bring it in and start to do analysis. So there's a lot of benefits by putting everything into one pot. So one thing we have to realize, of course, if you put your data into one pot, you also have to consume it from that one pot, right? So the engineers, they shouldn't just give their knowledge away and hope someone else will respect it. They should also make sure they respect the knowledge that comes out of the other disciplines, from the sales systems and manufacturing systems.
So this is the shared part, right?
Yeah, it's a shared part.
This is the collaboration.
Exactly.
I'm sorry,
so
go ahead,
CLM is about bringing things together, but also then consuming it from that place where it's brought together. And that just makes it a richer piece of information, a richer knowledge, because it's your product from all the disciplines collected in one place.
Well, and I can imagine this is what you're talking about, the solution here of CLM and what it's bringing to the table is solving problems that I think some customers maybe couldn't even or wouldn't even diagnose today as being related, right? So an example, I think from what you just described, you have a technical solution for a product that makes perfect sense, but as you go to bring it to market, only then do you realize it actually violates a sales rule, right? You say, oh, I can make it. It looks great, everything. And then you find out, back to the, air conditioner in the African market or something that is really nonsensical where you're like, well, yes, we offer an engine heater there, okay, why? Right? So to your point, if you can avoid late changes in product development, in manufacturing, in other places, if all the rules are understood up front, rather than having to try and apply them in different places. And it's part of this value of the sharing and the collaboration of the rule set, right?
Right. So it really basically enables us to do analysis before before we get into trouble, right? That's the whole point. So that common knowledge of your configurations brings a lot of value. We actually had a customer that experienced that during COVID, because I think a lot of manufacturing companies, they were in the position that when COVID hit the world, there was interruptions to supply chains, right? A lot of parts, you could no longer get them.
Right.
Things were late. There was a lot of chaos in that part. But it's very hard to answer the question, okay, if a part is missing, what is it that I have to take out of my offering? But if you have combined that information, you can do that very quickly. Because if you have your knowledge about what parts you cannot get anymore, you have information what drives that part. That information is basically configuration, and that can be tied straight over and say, "Hey, hang on, we need an extra piece of rule that prevents us from selling those combinations that can consume the part I can't get. Let's find alternatives. Let's upfront catch those examples before we actually get into trouble, because we don't want the product running down the production line and the part is missing."
Right. So, and the reverse, we've had some innovation, but now we're going to be able to do this option, feature, whatever it might be, much cheaper, much faster, whatever. Let's push that one in the market. All these permutations, right?
Exactly. So,
I find this part of the conversation is fascinating, because it's not, like I said, I think it's much easier for people to understand or envision how how CLM can expand your market, configuration can expand your markets, what you can offer to customers, et cetera. But the conversation of the additional value that it's bringing, I think, is really important. So this has been fascinating. Where I know do you have any last questions, Jonathan? Because you said you were saving one, but I think we covered that.
We got to model based. That's what I was saving, and I know I have more questions. However, I won't ask them. I know we can do this again in the future.
we definitely can. And it's funny. I think in our initial discussions, we thought, well, this will probably be 2 podcasts, and it has been, but I kind of feeling like it could be 3. Maybe it could be 4.
This has been good though, Anders. This has been really interesting to talk through.
Yeah. We really appreciate you, joining us and lending your expertise and helping out our listeners. And I do have a suspicion that we'll have you back. So,
all right. It's a pleasure being here.
Yeah. To all of our listeners, I hope that you have, you have listened to this and brought out some great value here. If there are remaining questions, if you would like to have Anders back, be part of the conversation, join us, let us know, give us some feedback. And matter of fact, if there are any other topics beyond configuration, because we certainly, again, it's all things digital related to products and manufacturing. So we're wide open there. I want to thank Anders for joining us and my co-host, Jonathan. And
absolutely.
Until next time, stay sharp.
Very good. Thanks, everybody.
Thanks.
Thank you. Bye.
Thank you for being here and listening to this episode of Stay Sharp with Razorleaf. If you have any lingering questions from this podcast, we'd love to answer it for you. Just leave a comment on our post or send an email to podcast@razorleaf.com. We appreciate all the feedback we receive. And don't forget to subscribe to our podcast on your favorite podcast platform. Until next time, stay sharp.